This video covers topic 12.1, adding and subtracting polynomials. When you add or subtract polynomials, it's basically a fancy way of combining like terms. So you're just telling me how many total x squareds, how many x's, and how many numbers. So on example 1, we're asked to simplify. We have 2x squared plus 3x plus 2, and we're adding in x squared minus 5x minus 5. So when I do this to show my work, I just use different types of underlines. This is also a place where you could use different colors or use different colors and different types of underlines. You can also rewrite and put your x squareds together, your x's together, and your numbers together. That's a little bit much, but you can totally do it. So I have 2x squareds on the left, and I'm adding in 1x squared on the right for a total of 3x squareds. Remember that the 1 is invisible, but it is there. So I have 2 plus 1. Then for my x's, I have 3 x's, and I'm taking away 5 x's. So 3 minus 5 is a negative 2 x's. And then I have 2 minus 5, so 2 minus 5 is a negative 3. And you box your answer, and that's all we're doing on adding or subtracting polynomials. So you're just combining your like terms. On example 2, we're distributing, so this time we have a subtraction sign here. So instead of doing what we did in problem 1, we have to add in one tiny step where we distribute the negative to everything inside of the parentheses. So negative x squared minus negative 4 becomes a positive 4x and minus 1. Now, I'm going to do like I did on problem 1. I have 2x squareds, and I'm adding a negative 1x, so 2 plus negative 1, or 2 minus 1 is just 1x squared. You do not have to put the 1. X plus 4x is a total of 5x's, and then negative 4 minus 1 is a total of negative 5. If you're not sure on those negatives, don't be afraid to use your calculator. Negative 4 minus 1, and I'm plugging in exactly what I see. I see a negative 4 and a minus 1 for a total of negative 5. So adding and subtracting, we're just combining like terms. If you have a subtraction sign, you need to distribute the subtraction and then combine your like terms. If you have an addition, just combine your like terms. Step 3 asked me to find, or problem 3 asked me to find the perimeter of the triangle shown. To find the perimeter of anything ever, we add all the sides. So for this problem, when I add, I have 3x squareds, 1x squared, and 2x squared. So 3 plus 1 plus 2 for a total of 6x squareds. For my x's, I have a negative 4, a positive 4, and a positive 3 for a total of 3. And then for my numbers, I have 7 plus 1 minus 5, so 8 minus 5, which is 3. And just put all that together in order, decreasing from biggest to smallest. So x squareds, then x's, then numbers. Okay, and again, you underlining, circling, squiggly lines, highlighting with different colors is you showing work. So as long as you're doing something like this, that's the most amount of work that we need you to show, but we do need you to show that. So problem 4, they tell me the perimeter of the triangle is 6x squared plus 5x minus 5, and two of the sides are x squared plus x plus 1 and 2x minus 1. What would be the third side? So if we draw a triangle, it can be any random thing. We have one side that's x squared plus x plus 1, a side that's 2x minus 1, and an unknown. And then I know that my perimeter is 6x squared plus 5x minus 5. So this one's going to have 2 steps in it. The first thing I'm going to do is find the length of the 2 sides. Okay, because remember on problem 3, we found the perimeter by adding all the sides. Well, this time I only know 2 sides. So with my 2 sides, I have 1x squared, I have an x and 2x for a total of 3 x's, and then I have 1 minus 1, which is just going to cancel. So to find my missing side, I'm going to take my perimeter and subtract the two sides that I just found. So the perimeter was given to me, and it's that 6x squared plus 5x minus 5. And then I'm going to subtract all of the x squared plus 3x. So just like we did on problem 2, I have to distribute the x squared, or I'm sorry, distribute the subtraction to the x squared and the 3x. So I'm taking my total perimeter and subtracting everything from the two sides, everything that I know to find out what I don't know. So 6x squared minus 1x squared is 5x squared. 5x minus 3x is a positive 2x. And then I just have that minus 5, and there's my answer. So if you're asked to find the perimeter, you add up all the sides like we did on problem 3. If you're asked to find a missing side when given the perimeter, you need to take your perimeter and subtract everything you know to find out what you don't know. Problem 5 asks us to find the area of the shaded region if 9x squared minus 6x plus 3 is the total and 3x squared minus 2 is the unshaded. So we know all of this, and we know this, and we want to know the shaded. So we know the full thing, meaning we're going to need some subtraction. So we're going to take the full thing, so the total, and subtract the unshaded to find the shaded. Again, we are subtracting everything that is unshaded. So we are subtracting 3x squared plus 2. We have to distribute that negative to everything inside of the parentheses. And then combine my like terms. I have 9x squared, I'm taking away 3 for a total of 6x squared. I have a negative 6x and no other x's to change it. And I have 3 minus 2, which is 1. Six asked me to find the total area of the figure if I have all of those pieces. All I'm really doing is adding in this plus y squared, y squared, y squared, y squared. So for this one, I'm just going to show I have 13y squared plus 1 plus 1 plus 1 plus 1. So 13 plus 1 plus 1 plus 1 plus 1 is 17y squared. And then I have a y, and I have a 4, and nothing to change those. So when you add or subtract polynomials, you're really just combining your like terms. You're saying how many x squareds you have, how many x's you have, and how many numbers you have. There are times, like on examples 4 and 5, where you're given a total and you need to subtract a piece. If you're given 2 pieces, it's best to combine those and then subtract. You don't have to. That's just best practice to make sure that you are successful in completing those problems.